All right. Welcome back. In this problem, we are going to find the area of this green region. Okay? If you want to solve this on your own, pause the video because I'm going to be back to solve this in just a few seconds. If you want to send this video to a friend who might find it interesting, that would be great. Okay, let's go. All right, so the first thing I'm going to do, we have two chords that are parallel to each other. Okay, these two chords are parallel to each other. This one's 16, this one's 12. The radius of this circle is going to be 10. So in a circle, if you have a chord and a radius or diameter, which is perpendicular to that chord, what that does is it bisects the chord. So the first thing I'm going to do is I'm going to draw a radius perpendicular to this chord down here. And when I draw that, what that does is it cuts this chord in half. And at the same time, I'm going to draw one down here as well, and it's going to cut this one in half. So this would be 8. This here is 8. This is 6. This one over here is also going to be 6. I'm going to draw another radius in here, and we know that radius is going to be 10. This radius over here, 10. This radius up here, also going to be 10. So now I'm going to use this right triangle right here, and we're going to do the Pythagorean theorem, where this is 6 and that's 10. And that's a Pythagorean triple where this one is going to be 8. So we know the height of that triangle is going to be 8. Okay, and then down here we have another right triangle. Again, the radius is 10, one leg is 8, so we know that this again is going to be a 6, 8, 10 right triangle. I'm going to clean this up a little bit over here. All right, so now we have a right triangle. I'm going to say that this angle is x degrees and this angle is y degrees. If I rotate this one around, then that would make this y degrees, and this one over here would be x degrees. Now we also know that in that right triangle, x plus y plus 90 has to add up to 180 degrees, so that means x plus y is going to be 90 degrees, which if we take a look at this diameter coming down, if this is x degrees, and this one's y degrees, that makes this here going to be 90 degrees. And the same over here, 90 degrees. So now we have this sector of the circle, which is 1/4 of the circle. This sector of the circle is also 1/4 of the circle. So these two sectors combined is going to be a half of a circle. So what we're going to do is we're going to find the area of a half a circle. So we're going to take pi r squared and divide it by 2. So the area is going to be pi times 10 squared divided by 2. So the area of these two sectors of the circle is going to be 100 pi divided by 2, so that's going to be 50 pi units squared for these two sections here. And then what we're going to do is we're going to find the area of the triangle on the top, area of the triangle on the bottom, and add them together to the 50 pi. So we're going to do area 1/2 of base times height. So the area is 1/2 of the base, which is 12, and the height, which is 8. So that is going to be 6 times 8. So the top triangle is going to be 48 units squared. And the bottom triangle down here is going to be 1/2 base times height. And the base of this is 16. And the height is going to be 6. So the area of that one is also going to be 48 units squared. So our total area is going to be the area of the two sectors here, which is 50 pi, plus 48 on the top, and the 48 on the bottom, So my final answer is going to be 50 pi plus 96 units squared. And that's the solution to the problem. I thought that was a really cool problem. If you enjoyed this video and would like to see more, please smash the like button and subscribe to my channel. I will see you on the next video.